Alrighty, gonna try this again. This is my take 2. New program, new stuff I'm learning. Trying my best. Miss you guys a lot. Hope you're doing well, and hope you're staying healthy. Hope you're staying home. Although staying home is really boring. Anyway, the next unit coming up that we're gonna be working on for the next, let's see here, like 2.5 weeks or so. It's called polar coordinates, polar graphs. It's the next 2 sections in your textbook. It's this one 10.7 and the next one 10.8. I realize that probably almost all of you did not bring your book home because you didn't know. I didn't give you any homework over the spring break weekend, so most of your stuff everything that you'll be given will be probably just virtually or like online submissions. But if there's something in your textbook that I just love and I just want to have you do, I will post a picture of it on Edsby for your reference. So don't worry about it if you don't have your textbook. I searched and hunted. There is no online textbook for me to just give to you. I know there's supposed to be. The district purchased it, but the publishers never gave access to us for it. So that's why at the beginning of the year when I kept saying we have online access stuff and you asked about it, it just never came to fruition, unfortunately. This would have been really helpful right about now. All right, so what we're going to do, real basic, real simple for this first thing is you're just going to plot some polar coordinates. Now, polar coordinates are this graph over here that I've got displayed, this right here. This is a polar graph. Now, this is technically overlaid on top of your regular XY axis. So, like if I were to trace over, and I could show you, like this is your, basic old x-axis, and this is your basic, y-axis here. So you got these concentric circle grids laid out on top of that in this polar graph. So I'm just going to take this off of there for you. Now, we are going to be plotting on that graph. So we are going to call this our first example. Oh, I probably would rather have it be black. So we will draw right on top of this thing, and this will be my first example. Why is it not dark? Oh, because I'm not using the right pen, probably. Bear with me, guys. This is all so new. Okay, let's try this now. There we go. Example 1, open. The yard is starting to get mowed, so here that just goes as well. All right, so when we're plotting, everything is in r, theta. So it's alphabetical order, but you're always going to want to start with the angle and then go to the circle with that radius. So if I wanted to plot the point, say this will be point A, maybe 3, pi over 4. I realize these angles on this coordinate grid are in degrees. That's all right. But we're going to go to the angle first, just like we normally would, standard form. And we're going to go out here to this angle first, and then I'm going to go out to the concentric circle from the origin of radius 3, plop a point right there, and label that. That's my point A. If I wanted to throw a, maybe 4, negative, 2 pi over 3, well, then I would rotate clockwise now to negative 2 pi over 3, which is here. And then on that angle, I would go out to a circle of radius 4 and plot that point, and that would be point B. We can also make the radius point, like that radius can be negative. So like you could say we want to go to maybe a negative 5 and maybe an angle of, we'll say 90 degrees, because you can convert to radians or degrees just like we did before. So if we wanted to do that, then we would say that that would mean we rotate first to the 90-degree angle, which is here, of course. But because the radius is negative, this right here just means that instead of being on this positive 90-degree axis, we have to go the opposite direction and plot 5 units from the origin down here. So that would be putting me right 1, 2, 3, 4, 5 right here on this circle, and that would be where point C is located. Okay, so the next thing that we're going to do is I'm going to put everything that was here in polar coordinates, I'm going to convert them into, I guess I'm going to leave that there. I'm going to put all of this into rectangular coordinates. So what that will do then is we will, let me just make this a little smaller so we've got room. We will mess this up, of course, because that's what I'm gonna do, because I don't clearly know what I'm doing. Okay, there we go. All right, so I'm going to say that this next example, we are going to be converting from a polar coordinate to a rectangular coordinate. And that just means that taking an ordered pair that would have been in the ordered pair r comma theta, we're going to transpose it into its regular old x and y comma ordered pair. So a perfect example would be if I utilize that point C. So if I grab that point C, -5, 90 degrees, that one is the easiest transfer to probably make because you can clearly see that would have been plotted at the point 0 for x, and -5 for y. We can do that with the points A and B as well, but I just wanted to show it to you on that one. All right, so if I was to do that to point A and B, let's start with point A. Go back to it. Point A was the ordered pair 3 pi over 4. So let's say that for point A, we've got, this will be continuing under, I guess, example 2. So point A was the ordered pair. So that one's pretty easy to do as well with all of the math stuff that you've already learned. That's what's so great about this, is you already know all the like computations that convert this stuff. So for example, what I mean is you already know things like, if I had a point over here, we'll call it x comma y, I already know that if I wanted to make that reference triangle, well then I already have the ability to, using the radius, which in this case is an r value of 3. So using my radius, r value of 3 from this problem, if r is 3, well then that tells me that I could figure out x and y by just doing a little Pythagorean theorem. I'm looking at a 45, 45, 90 triangle because I'm looking at a angle of pi over 4. So I know that this angle right here of rotation is a 45-degree angle. So with a little Pythagorean theorem, knowing that, let's switch colors for fun, x squared plus y squared equals r squared, and I could use that special right triangle. But we could also, knowing that, like, say, cosine, let's use a different color here. Knowing that cosine of theta is the, come back over here, I'm just pointing here, the adjacent side, which is x, over the hypotenuse, which is r. So I'm just writing that rule down again, knowing that cosine of theta is x over r, and knowing that sine of theta is y over r, from opposite over, again, hypotenuse. I also know that I could find my x coordinate by just doing r times the cosine of theta. I could find my y coordinate by just doing r times the sine of theta. And we've done that before. We did that when we did vector stuff right before spring break. So we've done this before, which means, well, then I can go back to the problem at hand, and I can make this real simple by saying that my x coordinate can be found by taking my radius, which is 3, and multiplying it by the cosine of theta, which is pi over 4. And my y coordinate can be found by doing my radius of 3 multiplied by my sine of pi over 4, and then that would then give me 3 times the square root of 2 over 2, my ordered pair would become 3 square root of 2 over 2, comma 3 square root of 2 over 2, which is the conversion from this polar coordinate. Okay? Pretty cool. That's just the regular old, like, I went over 3 square root of 2 units, and 3 square root of 2 over 2 units, up 3 square root of 2 over 2 units, and that's the same way that I got by rotating to pi over 4 and then going out to a radius of 3 units. Okay, so I'm going to give you some practice on that and see how you do. It's pretty straightforward.